Very good morning. I am audible. Very good morning.
Morning, ma'am.
So we start today chapter 8.3 or 8.3. I'm asking you quick. We start today 8.3 or something else. I'm audible.
Yes, ma'am. 8.3.
Yes. So 8.3 na? Okay. The net is very slow. Net is very slow. Pardon me. अच्छा, okay. Eight point three. Applications to physics and engineering. Applications to physics and engineering. Which way? Not like, is it? Okay. Physics and engineering. Here, you write down some formula. Moment of the system about the origin. It is written. Is it written this one? Movement of the system about the origin, movement of the system about the x-axis, y-axis. I am audible? I am audible?
Yes, ma'am.
It is written? Movement of the system?
Ma'am, we
Yes?
have only written y-axis and x-axis.
Only written. Y-axis and x-axis. So I am again writing. Movement of the system about the y-axis be, that is your m of y is equal to summation over I is equal to 1 to n mi xi. Moment of the system about the x-axis is mx is equal to summation over I is equal to 1 to n mi y. If limit n tends to infinity, if you say limit n tends to infinity, here limit n tends to infinity, then moment is your integration a to b, that is your value integration a to b rho into x fx dx. Okay? Here it is, and here it is also limit n tends to infinity rho a to b, that is your 1 by 2 fx square dx. Okay, that is the moment of the system. Now from that moment, center of mass, that is called a centroid. That is called a centroid. That is the value x bar and y bar. So x bar is equal to my by m. What is m? M is our total mass. Total mass. Then y bar is equal to mx by m is your total mass. Now here, this is in the integration form. If limit n tends to infinity, that I can write down x bar is equal to rho of a to b my, that is your x fx dx divided by, we know our m is equal to, I am not written, m is equal to, that is rho into integration a to b fx dx. So it is rho integration a to b fx dx. It is fx. So now it is cancel out rho. I can write down this is your area A is equal to, It is our integration a to b fx dx. So I can write down this is equal to 1 by a integration a to b x fx dx. I can write down this way. Similarly, y bar is equal to 1 by a to b, that is 1 by 2 fx square dx. Okay, so these are the formula here and here. I've done some problem or not? I've done some problem or not? I'm asking you.
No, ma'am.
Yes, ma'am.
Some example it is already done.
Yes, ma'am.
Achha,
Yes,
example,
ma'am.
find the center of the region bounded by the curve y is equal to cos x. It is done.
Yes, ma'am.
Okay, very good. Now, the region between two curves. The region between two curves.
Yes, ma'am.
Yes.
Yes, ma'am.
Region between two curves also over. So I think this article, sir, that means it is over. 32, 33 problem, class work. Question number 32 and question number 33. It is done or
Done,
not?
ma'am. Yes, ma'am.
Why you are wasting time there? So we'll start our chapter 10. So okay, we'll
Okay, ma'am.
start. Don't waste time. We have to finish your course tomorrow. Tomorrow you have 2-period class. You have to finish your course.
Tomorrow course over.
Huh? Yes, course over.
Tomorrow course will get over.
Yes. Only left 10.1, 10.2, 10.3. Don't worry. What I am going to teach to you, you follow that one. Okay? 10.1, 10.2, 10.3. Then it is your 11.1 and 2. Only these 5 articles left. And all are easy.
8.3, ma'am. Which questions?
Which one? 10 point?
8.3.
8.3, 32, 33 classwork. 32, 33 classwork. 8.3. And your assignment question is 24, 30, 35. Someone say it is already done. 32, 33. Someone says that it is already done, so that's why I'm not going to do. So I'm
No,
going to
ma'am.
start.
That was a previous exercise. Ma'am, this exercise we haven't touched yet.
You have not?
No, ma'am.
32, 33 not done.
No, ma'am. That was a previous exercise 32, 33. We have
Previous
done.
exercise 30, no 32, 33.
Yes, ma'am.
8.2 it is 2 and 14.
Ma'am, 32 means this question, right? Y is equal to x cube.
XQ, yes.
That is done.
X plus y is equal to 2.
Yes, ma'am. That is done. That
Done.
graph.
You know you are doing a graph, it is x cube like this. Here it is. I'm doing here. It is the graph of the x cube. And the curve it is given that y is equal to x, they intersect like this. Here, this portion. We divide it into two parts. Yes, this portion. We divide it into two parts. First, I am going to find out the area of this one. Then it is area of this one. Then we find out the center of mass of this one. Then we find out the center of mass of this one. Is not it? It is done or not?
Yes, ma'am.
Yes,
That is
ma'am.
done.
So similarly, that means 33 is also done. Okay?
Yes, ma'am.
Then now I'm going to the 10.1. Onwards, I'll only show you the PDF. 10.1 to 11.2, up to that. I'm going to show you your PDF here. Nothing is. What happened? So, did you 34 over 35, let it be 35. ମୁଣ୍ଡ ବଥେଇ ଯିବ ଏତେ ଟାଇମ୍ ନଉଛି। What is going on? ସମୟ ନଉଛି, how many times it is taking? ଇସ୍କୁ ମାର କୋଡ ମାରିଦେଲେଣି। पड़े होते हॉटस्पॉट Yes. Are defined by parametric equation. 10.1. So in parametric form, we define x as the function of t and y as the function of t. But t is the third variable we say, and according to the value of t, we have a point x, y on the curve. So when you write down that x is equal to function of t and y is equal to function of t, that is a parametric equation. T varies, the point varies that trace out a curve which is called parametric curve. So sketch and identify the curve, define, sketch and identify what type of curve. You may not get sketch, but you may get the identify the curve. Short question. Defined by the parametric equation. X is equal to t square minus 2t, y is equal to t plus 1. Okay, so the value of t lies from here, it is given that minus 2 to 4. See, minus 2 to 4. The t lies from minus 2 to 4. So what is done here? By considering some value, the points in between that minus 2 to 4, that is minus 1, 0, 1, 2, 3. So by substituting minus 2 here, I am getting the value of x is, I am getting the value of y is equal to minus 1. So according to that, we get all the value of that xy on the curve. So by substituting that value here, t is equal to minus 2, this point, t is equal to minus 1, this point, t is equal to, you see, this point is your 3, 0, this point is your 8 minus 1, this point, then t is equal to 0, this point, t is equal to 1, this, t is equal to 2, this, t is equal to 3, t is equal to 4, this point. So in total, we find out it is a curve, and that is looking like a parabola. That is looking like a parabola. So let us check that whether it is correct. Define the curve. So identify the curve here. So here, let us check that whether we are getting it is parabola or not. What we will do? We convert this parametric equation to the Cartesian equation. How we will convert it to the Cartesian equation? So you see, find out the value of t. T is equal to y minus 1. Substitute the value of t here. Substitute the value of t here. Then we get our equation, you see, by substituting the value of t here, you see, it is here. T is equal to y minus 1. We put the value t here. After substituting, we get this equation. This is your equation of the parabola. So now the curve represented by the given parametric equation is a parabola, that is our x is equal to this. You have to write down. So you may get such question here like this. What type of curve? Identify the curve. It option may be given to you. By considering, first you check how you check. Don't use that by considering t value. You put that value here, then you check that what type of curve it is first. That is the quick one. Then next example. What curve is represented by following the parametric equation x is equal to cos t, y is equal to sin t, 0 to t lies from 0 to 2 pi. All of you very well know that it is the equation of the circle. Because you see, x square is equal to cos square t, y square is equal to sin square t, x square plus y square is equal to 1. All of you know it is your equation of the circle is x square plus y square is equal to r square, passes through the center is at origin and radius is our r. So here we get it is our x square plus y square is equal to 1. So it is our Cartesian equation. When we write down x square plus y square is equal to 1. It is our Cartesian equation, and we say that here our center is origin and radius is our one. So here next, you see the figure. If you consider the value here like t value, you must get it is 0 to 2 pi. You must get it is a circle. If t is equal to pi by 2 this point, t is equal to pi is this point, t is equal to 3 pi by 2 is this point, t is equal to 2 pi is this point. Starting point and the ending points are same here. So we are getting it is a circle here. So it is your not necessary. Familiar part, it is also not necessary. So, okay, over. Solution of classwork, question number 6. Classwork problem, it is question number 6. Sketch the curve by using the parametric equation to plot point. Indicate with an arrow the indication in which the curve is traced as a t increases. So for this question, you may not get the sketch the curve, but identify the curve you may get. What type of curve it is, you can identify. Indicate with an arrow the direction in which the curve is traced as t increases. Then bit B, eliminate the parameter to find out the Cartesian equation of the curve. And this question also you may get, short question, multiple choice question. So here, the curve it is given to you, parametric form of the curve is given to you, x is equal to 1 minus 2t, y is equal to t by 2 minus 1, and t lies in between minus 2, 4. So what we will do here, first t lies though it is minus 2, 4, we consider some points in between that is minus 2, minus 1, 0, then 1, 2, 3, 4. You see here. And find out the value of x point xy on that curve. Here it is. So when I am putting the minus 2, I will get it is 5, minus 2, minus 1, 3, minus 1.5, 0, 1, minus 1, 1, minus 1, minus 0.5, 2, minus 3, 0, 3, minus 5, 0.5, 4, minus 7. By drawing the figure here, by substituting all the value here, we get it is the equation of this straight line. We get a straight line. You see. And though it is started from minus 2 to 4, so it increases like this. Minus 2, so it increases like this. So here we get by putting all that point. So here we get it is a straight line. By joining that point, we get it is a straight line. So you may get this short question, what identify the curve. So you write down it is a straight line. It may be given to you as the multiple choice. Okay. Then the question is you convert it to the Cartesian form. Convert it to the Cartesian form means here what we do, here you find out the value of t here or here anywhere. T is equal to, here it is x 1 minus x divided by 2. That value here you put, then we simplify, then we get that is the Cartesian equation. And there also you must get it is just equation of this straight line, you see. Here it is 1 minus 2, t is equal to 1 minus x by 2. So y is equal to 1 by 2, they put the value of t here, minus 1, we get this. So here simplifying, we get y is equal to minus 1 by 4x minus 3 by 4. So x lies from where to where? See? X lies, the domain is here from, you see it is here minus 7 to 5. Y lies from minus 2 to 1 here. So x lies from minus 7 to 5. Okay. So this is the question given. You have to do it like this. That is your question number 6. Next, question number 21. Describe the motion of a particle with position x, y as t varies xy as t varies in the given interval. The curve is defined as x is equal to 5 sin t, y is equal to 2 cos t. And t lies here, it is given as minus pi to 5. Though the cos x function and sin x function, it is period 2 pi. So first we find out the value of xy in between minus pi to pi. So period is 2 pi. Okay. So here, by considering the value, you see it is t is equal to minus pi, the value of x is equal to 0, and the value of y is equal to minus 2. Similarly, it is then minus pi to minus pi by 2, then 0, then pi by 2 to pi. So we consider all this value, we get this value. Now listen here. The initial point, when I'm starting from the minus pi, the initial point, it is your 0 minus 2. And the terminal point, when it reaches pi, again I'm getting the same value, 0 and minus 2. So here it moves one revolution at pi, starting from minus pi to one revolution at pi. Clear? All of you clear this point? All of you clear? I'm audible? I'm audible?
Yes, ma'am.
Okay. So one revolution at pi. Clear here? Because starting is here at minus pi and we are getting the same value at pi. So we get here it is one revolution. You can say it is here one revolution at pi. So one revolution, though it is at pi, starting here, then again we reach at starting minus pi, say if we say pi, so here again we reach here, so we get it is 0 minus 2. Now, so the next revolution, it should be plus 2 pi. Second revolution, pi. One revolution first at pi, then the second revolution, pi plus 2 pi. So
Yes,
at
ma'am.
3 pi, we have second revolution. It is clear? It is clear?
Yes, ma'am.
Then third revolution given as 5 pi. So it is 3 pi plus 2 pi. It is your 5 pi. So the third revolution is at 5 pi. Okay. So here, and what type of equation it is? It is given as x is equal to 5 sin t, y is equal to 2 cos t. I can write down x by 5 is equal to sin t and y by 2 is equal to cos t. That is your x square by 25 plus y square by 4 is equal to sin square t plus cos square t is equal to 1. So it is the equation of?
Ellipse.
Yes. So we have a ellipse. That ellipse, first revolution, complete first revolution at t is equal to pi, complete second revolution at t is equal to 3 pi, completes third revolution at t is equal to 5 pi. Clear? So here, you see the figure. Here it is, starting from this, again it moves anti-clockwise. The direction of the curve is anti-clockwise motion. You see, your values
Ma'am,
are, yes,
clockwise direction.
no clockwise. This direction is called as anti-clockwise. This direction is called, sorry, it is your, it is clockwise, it is anti-clockwise. Sorry, yes, it is clockwise, it is anti-clockwise. Sorry. So here it is your clockwise direction. It is moving your value by substituting the value. We are getting this point, then this point, then this point, then this point. Again, we are getting this point. Then other revolution here it is pi to 3 pi. Again, we get this, and the third again we get this. You can check. So here it is your curve clockwise with the clockwise direction. So now assignment is given 7, 19, 20. Over
Yes,
7,
ma'am.
19. Next, here. Calculus with parametric curves. Suppose f and g are differentiable function, f and g are differentiable functions. And we want to find out the tangent line at a point on the curve where y is also a differentiable function of x. It is not written here, it is of x. Then by using our chain rule, we know it is dy by dt if you write down dy by dt, that is your dy by dx by dt. Where I can write down the tangent dy by dx, y is the function of x and it is differentiable at x, then dy by dx is equal to dy by dt divided by dx by dt. Provided dx by dt
Ma'am, you are not audible.
provided dx by dt is not equal to 0. 2. If dx by dt equal to 0, if it is equal to 0, then we are getting the infinity value. Provided a curve has vertical tangent, provided dy by dt is not equal to 0. If it is equal to 0 and it is equal to 0, then it is undefined. So provided that dy by dt is it is not double y, it is only y. Y is equal to tq minus 3t. X is equal to t square. Y is equal to tq minus 3t. The curve is defined by the parametric equation so that C has two tangents at the point 3, 0. The curve has two tangents at the point 3, 0. And find their equation. So you have to find out the equation of the tangent at the point 3, 0. Two tangent at the point 3, 0. So what we will do here? Equation of the tangent, that is our dy by dx is equal to, you have to find out dy by dx is equal to dy by dt divided by dx by dt. Okay. So dy by dt is our 3t square minus 3 and dx by dt is our 2t. Okay. So for the horizontal tangent, dy by dt is equal to 0. So 3t square minus 3 is equal to 0. Okay, here it is written. Yes, you see. So here you see, at the point 3, 0, the value of x is t square is equal to, it is given as 3, and the value of tq minus 3t, it is given as 0, equal to 0, at this point on the curve. By substituting any value of t here, I am getting, so from that, what is the value of t? We get that value, it is here, y is equal to tq minus 3t is equal to this value, here it is t is equal to 0 or t is equal to plus minus root 3. So we cannot consider t is equal to 0. If I consider t is equal to 0, it is 0 and this value is 0. So we consider t is equal to plus minus root 3. Therefore, the point 3, 0 on the curve arise two values of the parameter, that is here for the value root 3 and plus root 3 and minus root 3. Okay. So t is equal to plus root 3. What is the value we are getting here? dy by dx is equal to, I say 3t square minus 3 divided by 20, that is 3, 2, it is here. So by substituting t is equal to root 3 plus minus root 3, we get dy by dx is equal to this way. That is here plus minus. By simplifying, here it is also plus minus root 3. So equation of the tangent at 3, 0 are y is equal to root 3 x minus 3, that is 0. You see, equation of the tangent y minus 0 is equal to root 3 slope, that is root 3 into x minus 3. Similarly, y minus 0 is equal to minus root 3 x minus 3. So the two tangent passes through this point. Here 3, 0 is our this. Then what is the question asking? Two tangent, find their equation. Find the point on C where the tangent is horizontal or vertical. Find the point on C where the tangent is horizontal or vertical. So if tangent is horizontal, we know dy by dt is equal to 0. dy by dt is equal to 0 means 3t square minus 3 is equal to t square is equal to 1. So the value of t is equal to plus minus 1. If t is equal to plus minus 1, the corresponding value of x and y, we are considering as x is equal to, it is your given as t square, and y is equal to given as 3tq minus 3t. The value of x and y, when we get the value t is equal to, for the horizontal tangent, plus minus 1, we get the value x is equal to 1, tq it is, t square, sorry, it is t square, x is 1, and y is equal to, t is equal to 1, y is equal to t is equal to 1, the value of y is equal to your, it is 1, tq to 1, 3 minus 3, 3t square minus 3. What is given here? 3, the only tq is, it is tq minus 3t. So y is equal to 1, it is your 1, minus 3, it is minus 2. We get 1 point. So in minus 1, also it is the value 1. In minus 1, it is your minus, and it is plus, so get it is 2. So here we get the value, the corresponding value for the horizontal is, your points are 1, minus 2, and 1. For the vertical tangent, you know it is a dx by dt is equal to 0, that is 2t is equal to 0, or that is t is equal to 0, and dy by dt is not equal to 0. So if t is equal to 0, there are other value, also t is equal to 0, x is equal to 0, and y is equal to 0. This is the point for the vertical tangent. Then the question asking, here the third point of the question is your, find the point on C where the tangent is horizontal, vertical, circular. Determine whether the curve is concave, upward, or downward. C is our concave, upward, or downward. So to find out the concave, upward, and downward, we have to find out the second derivative. We have to find out the second derivative. It is your t square. It is not r square. D by dt of dy by dx, d square y by dx square. This d by dt of dy by dx divided by dx by dt. That is our value here in this one. And it is concave upward when t is greater than 0, and downward when t is less than 0. Only simply write down. And the d is your sketch the curve. You may not get this to sketch the curve. Here you say horizontal tangent. Two tangent crosses at the point 3, 0. Okay, a vertical tangent at 0, 0. So now area. Now you have to convert that area into the parametric form. We know we find out the area, that is the integration from a to b fx dx, where y is the function of x. We know it is, where fx is greater than 0. Then here we have to convert it to the parametric form as x is the function of t and y is the function of t, and t lies from alpha to beta. So area A is equal to this one. I can write down it is as a to b y dx. So the value of y is equal to gt, and there the value of dx is equal to f dash t dt. We can write down here in this way. And the t lies from, though it is alpha to beta, we have to put the limiting value according to that. Here y dx. Then find the area under one arc of this cycloid. Find the one arc means the arc lies in between 0 to 2 pi. So one arc is our 0 to 2 pi. So here it is written. Cycloid is given by 0 to 2 pi. So x is r theta minus sin theta, y is r 1 minus cos theta. So we know our integration area A is equal to 0 to 2 pi, that is your y dx. The value of y is equal to 1 minus cos theta, r 1 minus cos theta, and the value of dx is equal to here 1 minus cos theta. So we put it here. So then we simplify. 0 to 2 pi.
Ma'am,
Yes. Curve.
ma'am, what is the meaning of cycloid?
That is one type of curve. That is curved like this. That is one type of curve lies from 0 to 2 pi. Always. Okay. So here it is. Solve 1 minus x square d theta. Our parameter is here theta. So by solving, it is converting as the cos square theta. That is 1 plus cos 2 theta by 2 d theta. And this is our 1 minus cos 2 theta. Then we solve. Getting the value 3 pi r square. Then come to the arc length. Arc length is our, we know arc length L is equal to A to B root over 1 plus dy by dx dx, where y is the function of x and x lies in between A to B. If x is the function of y and y lies in between C to D, what we are writing that arc length? L is equal to C to D root over of 1 plus dx by dy square dy. Okay, so now here it is dy by dx is equal to dy by parametric form. X is the function of t and y is the function of t, and t lies in between alpha to beta. So we can write down dy by dx is equal to in this way. So provided dx by dt is not equal to 0 or it is greater than 0, it is written here. So here what we get? See here, taking the denominator dx by dt square, it is dx by dt square here plus dy by dt square. By removing that root over, so we get here it is dx by dt. So dx cancel out, we only get dt, that is go up here. Clear or not? Here we'll get this is equal to root over of it alpha to beta. We'll get it is our dx by dt square plus dy by dt square, then divided by root over of dx by dt square. Okay, so if you take the root over of the denominator, then it is your given as dx. So if you consider this alpha to beta, Then here it is dx by dt square plus dy by dt square. Then it is your dx by dt. Then it is dx. So these two cancel out, and this is go up. That is your dt. Right. So okay. So to go, so we'll get this. So this is by using the parametric form. This is the equation. You get the same value if x is the function of y also. You get the same value, that is here only the value it is dy by dt, and dy it is cancel out and it is go up. The same value you get here, whatever may be the functional value, it is either y is the function of x or x is the function of y. The same equation we will get here. So find the arc length, find the length of the arc of the cycloid, that is here again. X is equal to r theta minus sin theta, y is equal to r 1 minus cos theta. Okay. Parametric interval 0 to 2 pi. Always our interval t lies, or if you say it is t or a theta, here it is. Always it is for this cycloid cardiac, that is your 0 to 2 pi. So here it is our curve dx by d theta. We have to find out dy by d theta. Find out, and the arc length it is your 0 to 2 pi. We put here. Then we simplify and take r outside. It is your 1, 1 plus 1, 2. To take out 1 minus cos theta. Okay. Here it is written, you see here, solving 1 minus cos theta. You know your sin square theta is equal to, it is solving like this, sin square theta is equal to 1 minus cos 2 theta divided by 2. You know it is? You know
Yes,
like
ma'am.
this? Okay. So if I write down here, it is as 1 minus cos theta. It is your 1 minus cos theta is and cos theta by 2. I'm writing here by
sin square
considering
theta.
2 theta as a simple 1 theta, that is your. Then we write down it is our sin square theta by
Sin
2.
square.
Yes, I can write
Yes,
down
ma'am.
like this. So it is 1 minus cos theta. I can write down it is your sin 2 sin square theta by 2. I can put here 1 minus cos
Yes,
theta.
ma'am.
1 minus cos theta is equal to 2 sin square theta by 2. I can put, okay. But theta always lies from 0 to 2 pi. So if theta is less, 0 is less than equal to theta is less than equal to 2 pi, then 0 is less than equal to theta by 2 is less than equal to pi. For this
Yes, ma'am.
integral value, so by substituting that integral value here, consider our value. It is a root over of this 4 sin square pi theta. It is your value sin 2r 0 to 2 pi. So this value here. So you get, then substitute here, it is your 2r, it is your minus, it is 2, it is cos theta by 2, then it is 1 by 2, so 2 is go up, it is cos theta by 2, 0 to 2 pi, it is 0 to 2 pi, 0 to 2 pi, the value, then we get. Okay. Two 1 minus cos theta, it is 2 sin square theta, so it is root over of 4 by 2. So it is, I'm getting it is here 2 into sine theta by 2. I'm putting the value here. Nice. Then surface area, same. Rotation about the x-axis, we know our formula is a to b 2 pi y root over if y is the function of x. That is your ds value is root over of 1 plus dy by dx square dx. If x is the function of y, then it is root over of 1 plus dx by dy. Okay, so the same way here also we get it is our rotation about the x-axis, it is our alpha to beta 2 pi y. Our radius is y, already I told you. And this value is same, whatever may be the functional value, if y is the function of x or if x is the function of y, it is same. And rotation about the y-axis, that is here it is 2 pi x, and this value is, it is same. So ds is same for both the case, only the rotation about the x-axis is 2 pi y, the circumference you have to write down, and rotation about the y-axis is circumference you have to write down 2 pi, it is your ds, it is wrong, 2 pi x. So okay, so here, so by using that, show that the surface area of the sphere of radius r is 4 pi r square. The sphere is obtained by rotating the semicircle. Here it is given r, x is equal to, you know, it is r cos t, y is equal to also it is r sin t, it is wrong here. And t lies from 0 to pi. T lies from 0 to pi. About the x-axis, write down 2 pi y, the value of y is equal to r sin t. Then it is your dx by dt square plus dy by dt square dt. Then simplifying, we must get the value, which is 4 pi r square. Then come to the solution problem. Okay, we'll discuss the solution problem, though it is 10:59. So all of you clear up to this? All of you clear? Parametric
Yes,
equation.
Yes, ma'am.
So tomorrow we discuss this classwork problem. Only 2 problem you have, I think. You can do this one yourself because already you know the example. And it is 2 problems. Not necessary to do this curve, you will not get here. Then it is your 29. Last 9:43. Okay, we discuss tomorrow this problem, then 10.3, then 11.12. We have to finish tomorrow because I don't know, you have another class on Friday. I don't know if the class may continue on up to that. If it will continue, then it is okay. But I have to finish. Be ready for that. So I'm going to stop now. I'm going to stop. Okay? Just stopping.